Okay, so what we're going to look at next, so we've already done simplifying exponents, solving exponential equations, as well as logs, evaluating a log, and condensing and expanding. So now we're going to look at how do we solve an equation that's in log form. So before we get started, I'm just going to write our definition of a log, also what we use to convert. So that way we have it up here to use. So our log form is on the left, our exponential is on the right. So this way I can easily see how I convert. Because when we solve log equations, we do a lot of converting from form to form to help us isolate x. Something else that you'll want to note is we had talked about this in exponential form when we had a to the m equals a to the n. We knew then that m would have to equal n. We have something just like that with logs. So if I have log of a equals log of b, so I have a log with the same base, so let's actually call this base m, because it doesn't have to be a base 10, it can be any base. If you have the logs with the same base, then you can say a is equal to b. So again, something we can use to help us condense and then drop the logs so that we can solve for x in an easier way. So these are two other facts that we're going to use, as well as our definition to be able to convert back and forth when necessary. So let's go ahead and go through some examples. All of these we're solving. So on all of these we are solving for x or y or whatever the letter is. So our first one, log base 7 of x minus 1/2 log base 7 of 4 equals 1/2 log base 7 of 2x minus 3. So when I look at this, I see that I have a lot of logs. I have logs on the left, I have logs on the right. So because everything has logs, there's nothing without a log. I'm going to think condense and try to use this. So condense them, and then so I have a log on each side so that I can drop the logs and set what's inside equal. So if I look at condensing, the 1/2 coefficient here can come in as my exponent. And then the minus, that means we're going to divide. So I can condense this further. Log base 7 of x divided by, and 4 to the 1/2 is 2. So I can write it as x over 2. So I've condensed the left side down to 1 log. So now I'm going to do the same thing on the right. This 1/2 can come in as my exponent. So log base 7 of 2x minus 3 in parentheses to the 1/2 power. And that's as far as it goes. So I'm just going to copy that down here so it matches with my final step. So I've condensed both sides. Since they're both log base 7 on either side, that means I can drop the log, so essentially cross those out, and write the equation x over 2 equals 2x minus 3 to the 1/2. That's what this property right here is letting us do. And it's the same way we did it with exponents, we're just doing it with logs. So from here, how can we solve this equation? Now we're back to just algebra, the stuff we've been doing. So how can we get rid of a 1/2 exponent? We get rid of that by squaring both sides. So we'll have x squared over 4 equals 2x minus 3. I don't like the fraction, so now I'm going to multiply everything by 4. I'm going to bring it over here just so that I have a little bit more space. I'll have x squared equals 8x minus 12. So now I have a quadratic, so I'm going to move everything to one side. So subtract the 8x, add the 12, and try to factor. So minus 6 minus 2, and we get x is equal to 2 and 6. Now something about a log. Actually, are we talking about that here yet? Yeah, I'll talk about that in class tomorrow. So these would be our two values of x that we could possibly use to help us within our, to help us solve for x. So again, how I started this was I looked to see what I had. Do I have exponential? Do I have logs? Do I have both? So since this one was all logs, I condensed each side so that I got a single log on either side. That would allow me to set these two equal to one another so that I could solve it using a quadratic in the end to get my x's. Okay, we're going to do a second one here, and this is still a log, but it might look a little different. And let's see if you remember. Okay, ln. ln is a log. It's a special log. So we have log base 10, which is the common log. So when we see just log of a number, that's the same as log base 10 of that number. We just don't write the base 10. When we see ln of a number, that's the same as log base e of our number. E is a special number. It's one that's pre-programmed in your calculator like pi, so you don't have to worry about memorizing it. But we do have a shorter way that we write it, and we write it as an ln to show that it's the natural log as opposed to a log with a different base. But it's still a log. Treat it the same laws, same everything. It's just got its own special notation so that rather than writing log base e, we write ln. So when we go to condense, because I noticed that again, just like number one, I have logs in all three spots. So I'm going to do the same thing I did on number one. I'm going to condense the left and condense the right so that I have a single log on either side. So to condense the left, I'm going to bring that 1/2 in as an exponent. On the right, I'm going to bring the 3 in as an exponent. And then that minus sign, so I'm just copying down the right or the left side at the moment, the minus tells me I'm going to divide. So 5 to the third is 125 divided by x. So once we have a log on either side, we can drop the log and write the equation x to the 1/2 equals 125 over x. So from here, let's see, I'm going to multiply both sides by x so I can get my x's together. So I have 125 on the right and x to the 3/2 on the left, because that's a 1 and I'm adding my exponents, so 1 plus 1/2 is 3/2. And then we have to figure out, okay, how do we get rid of that exponent or move it to the other side? If we raise both sides to the 2/3 power, the exponents on the left will cancel, giving us just a 1. So we have x to the first. And now we just need to rewrite the cubed root of 125. squared. So the cubed root of 125 is 5, and 5 squared is 25. Okay, so these first two followed a very similar process where we went and got a single log on either side by condensing using our log laws so that we can then pull out just the a terms so that we could solve for x using algebra, whether it be quadratic, radicals, or whatever. The next one I want to go through is going to look a little different. And we're going to use a little bit different of a strategy. And this will be the last one that we do for our notes tonight. Okay, this next one log base 2 of log base 3 of x equals 2. So this last one is a log within a log. And you'll notice that we only have a log on one side, not the other. So it's different from the first two that had logs on both sides that we could simplify and then be able to drop the logs on either side. We can't do that here because we don't have a log on both sides. So this is one where we're going to actually use the definition of a log. So I need to think of this here as my a. All of that right now is inside of that log 2. Here's my base, and here's my x. So if I go and write this as an exponential form, I have my base, which is 2, to the x power equals my a term, log base 3 of x. Actually, that's not to the x power, that's to the 2. Oops. Sorry, put x instead of 2. So right there, I've rewritten the outer log, that log base 2, in exponential. 2 squared I can rewrite as 4. And I can do this process again, write it as exponential, because I still have the same issue where I have a log on one side but not the other. So what I'll do again, x is my a, 3 is my b, 4 is my x. These letters again are referring back up to our definition at the very top of how to convert. So if you're wondering where the a, b, and x are coming from, they're the parts here so that I can make sure I match them correctly in my exponential. So my base of 3 to the 4th power will equal x. So b to the x equals a. 3 to the 4th is 81. And we have our solution. So these are two of the ways that you're going to be solving for logs. Sometimes you'll have to do this conversion to exponential because you only have logs on one side of your equation, not the other. If you have logs on both sides of your equations, like 1 and 2, then you condense each side to one log and then drop the logs and set what's inside equal. We have about, let's see, I have at least 1, if not 2 more that I want to do in class with you. That could be a little tricky. And then I'm also going to talk about when you might have a no solution to a log, because that'll come up as well. So for right now, if you at least can understand these two methods and when to use them, that's all you need to know.